Welcome Algebra 1. This video is 10-3, Operations with Radical Expressions. The essential question is, what is a radical expression? Let's begin. So, a few vocabulary words. What are like radicals? Like radicals have the same thing inside the radical sign, so the square root sign. So square root of 11, 2 times square root of 11, and negative 3 times square root of 11 are all like radicals because they all have 11 inside. Now, unlike radicals have different things in the radicals. So this is square root of 11, square root of 10, and 2. These are different, so those are not like radicals. Now, you can add the same radicals, or like radicals, like you add variables. So if you did 3x plus 4x, you know that's 7x. Well, 3 square roots of 2 plus 4 square roots of 2 equals 7 square roots of 2. You're adding it just like you would like variables. And you subtract it the same way as well. So 5x minus 2x would be 3x. So 5 square root of 2 minus 2 square root of 2 is 3 square root of 2. Just like with variables. Okay, so let's try a few other examples. 2 square roots of 11 plus 3 square roots of 11. That's 2 plus 3 will be 5 square roots of 11. Now 10 square root of 11 minus the square root of 11. Since it's just the square root of 11, you treat it like there's a 1 there, so it becomes 10 minus 1, which would be 9 square roots of 11. And 3 square root of 5 plus 5 would be 8 square root of 5. Alright, so sometimes you have to simplify one of the fractions first. So if I want to do square root of 2 plus square root of 8, well, I want to make it so that those radicals simplify as much so the radicals are the same. So I'm going to simplify that square root of 8. And using the step method here, you do the 8, and then I pulled out, well, it's down here. So pull out a 2, you can get a 4, pull out another 2, and you're left with 2. A pair of 2's and a lone 2, that square root of 8 is equivalent to 2 radical 2. So instead of this, I now have this new equation as square root of 2 plus 2 times square root of 2. That's 1 square root of 2 plus 2 square root of 2 equals 3 square roots of 2. Alright, so let's try a different one. What's the simplified form of this? Well, I have a 5 square root of 3 minus square root of 12. I'm going to reduce that square root of 12, and if you do that, you can get a pair of 2's and a lone 3. So what you have for that square root of 12, I now have 5 square root of 3 minus, outside will be a 2 square root of 3, which will simplify to 3 square roots of 3. Because 5 minus 2 is 3. Alright, try a different one like that. So both of these are going to have to be simplified. I'm going to do 32 first. So 2, 16, 2, 8, 2, 4, 2, 2. Pair, alone. So that simplifies to 5 times 2 is going to be 4 square roots of 2. Minus, and let's simplify the square root of 18. So 9, 3, and 3. A pair of 3's and a lone 2. So that's going to be 4 times 3 on the outside, square root of 2. Did the parentheses because you have to multiply by the 5 times the reduced radical. And the 4 times reduced radical. So multiplying that out, that'll be 5 times 4 is 20 square roots of 2. Minus 4 times 3 is 12 square roots of 2. And if you do the math there, 20 minus 12 is going to be 8 square roots of 2. Alright, let's try something else. So you can multiply radicals as well. So the square root of 10 times the quantity square root of 6 plus 3, I am going to distribute that square root of 10. So that's going to become square root of 10 times square root of 6 will be square root of 60 plus 3 times square roots of 10. Now can I simplify that anymore? Well, if you can simplify the square root of 60, you can. Now I'm going to try to reduce that 60, and a 2, and a 30, and a 2, and a 15, and a 5, and a 3. So a pair of 2's and a lone, so that's going to be 2 square root of 15, 5 times 3, plus 3 square root of 10. That doesn't simplify anymore because that 15 and 10 do not combine. So I'll leave my answer like that, and that is the simplified form. Now try this other one. I can FOIL these, so it's multiplying binomials, just like there were variables here. So I'm going to do the FOIL method. Square root of 6 times square root of 6 is square root of 36. Square root of 6 times square root of 3 is going to be plus square root of 18. 2 square root of 3 times square root of 6 is going to be negative 2 times 3 times 6 is square root of 18. And then the last one, negative 2 square root of 3 times square root of 3 is going to be minus 2 square root of 9. Okay, so if I simplified that, square root of 36 is just going to be 6. This 1 square root of 18 minus 2 square root of 18s, I'm going to combine them to be minus 1 square root of 18, or just minus square root of 18. And the square root of 9 is going to be 3, so that becomes minus 2 times 3. So negative 2 times 3 is going to be negative 6. So I have 6 minus square root of 18 minus 6. And that's going to equal 6 minus 6 cancels each other out because positive and negative opposite numbers. So it's going to be negative square root of 18. And I can reduce that square root of 18. 3, 6, 3, 2. Parent alone. So that's going to equal negative 3 on the outside and square root of 2 on the inside. So there's my simplified form. All right, last example here. So conjugates. This is another topic here. So vocab word. Conjugates are the sum and difference of two terms. So, for example, conjugates, another way to say this is you're having a binomial here, and it's just the same numbers or same term on each side, but one's going to be positive and one's going to be negative. So, for example, I guess this isn't a good slide for that, but oh well, we'll work with this. So, some examples for conjugates would be square root of 7 plus square root of 3, and then the conjugate for that would be the square root of 7 minus square root of 3. Another examples would be 5x minus 3 and 5x plus 3. These would be conjugates because one is plus and one is minus. So we have to know what a conjugate is because when you multiply two conjugates together and there's square roots like this, the product of two conjugates is the difference of squares. So we're using that formula a squared minus b squared equals a minus b times a plus b. Back in last quarter. So if I want to simplify the form of this equation down here, I don't like having square roots on the bottom. I'm just going to slide this down a little bit. So what I'm going to do is I'm going to multiply the top and bottom by the complex the conjugate, just the conjugate. So you have this at the bottom. I'm going to multiply the top and bottom by square root of 7 plus 2, square root of 2, over square root of 7 minus square root of 2. So on the top, there'll be a lot of math here. You're distributing that 10, so you'll get 10 square root of 7 plus 10 square root of 2. And in the bottom, you're going to multiply these out. Now, if you know if it's difference of squares formula, you could follow this and say, oh, it's going to be square root of 7 squared minus square root of 2 squared, which will be the square roots and the squares cancel out, 7 minus 2, which will be 5. If you don't want to do this, you could multiply a binomial with FOIL. But I'm going to skip doing that for now. So it's just going to be 5 on the bottom. And now I want to reduce as much as possible. So what I can actually reduce, there's two terms on top and one on bottom, and they all divide by 5. So I'm going to reduce all those by 5. And then the one I don't need the denominator anymore. I'm going to get 2 square roots of 7 plus 2 square roots of 2. And that's my simplified form. That's it.